Another sorting algorithm that is done in n log n time is the QuickSort method. So let's jump right in. We're going to sort this array of integers with the QuickSort. So to start the QuickSort, we take the last element of the array and we call that our pivot. The other term that we're going to need to know is the wall. So right now when we start, the wall is going to be at the very beginning, and the goal of the wall is to have at the end of each iteration, we're going to have all the elements that are less than our current pivot to the left, and all the elements that are greater than the pivot to the right. So let's begin. If 3 is our pivot, and our wall is here, we start with 7 as being the current element. So 7 is greater than 3, and it is already to the right of the wall, so we don't need to move it. The same is true for 6. So then moving on to 2. 2 is our first element that is less than 3. So what we want to do to 2 is switch it with the closest element to the wall, to the right of the wall still. And place it there. So now we move the wall over 1 because 2 is less than 3, which is going to replace the wall eventually. Moving through the rest of the array, we see that 3 has no more elements that are less than it. So to place 3 at the position of the wall, we switch 3 with the element closest to the wall but on the right side. Now with our new array here, 6 becomes the pivot. So 6, and the wall is here, so we start with the current element after the wall. So 7 is already greater than 6, so we don't need to move it. 4, however, is not. 4 is less than 6. So if our wall is here, we switch 4 with that, leave it there, and then our wall shifts forward once again. Then moving through, we get to 5, that's also less than 6. So then we're going to switch the 7 there. Moving through, so no more elements are less than 6. Our wall is shifted now to be greater than the 5. So now that we've done with the iteration with 6, we can switch 6 there, and ta-da! Our array of integers is sorted with QuickSort.